Here's our given information for this question. You can see that we're already given a pair of congruent triangles. Triangle UWX is congruent to triangle VXW. I'm going to highlight those two just so you can see the ones that are already congruent to each other. That's triangle UWX, that's this one here, is congruent to triangle VXW. That's this one here. Okay, we already know that those two triangles are congruent. That's based on the given. Now, let's talk about what we need to prove. I'm going to change the color of the highlighter here so that you can see a little bit more clearly what we're trying to prove. What we're trying to prove is that UVW, that's this triangle, is the same as VUX, that's this triangle. Okay? That's what you're trying to prove. Now, let's see what we can do from that. So we're going to start with this initial statement, which of course is given to us, which is that UWX and VXW are congruent. What does that tell us? Okay, watch. The first thing it tells us is that side UX is congruent to side VW. We get that right from the naming right here. Look, 1, 3, 1, 3. That's where this comes from right here. And we can make that statement because we already have a pair of congruent triangles. So our reason then would be CPCTC. We can say that these parts of these congruent triangles are congruent themselves at CPCTC. All right, UW and VX. So UW, that's going to be this long line right here. And VX, that's going to be this long line right here. Those two are congruent, again, as parts of those original triangles. So that is also a CPCTC. Now, if you're able to see the green triangles that I highlighted, here's one of them. See that? There's a green triangle. Notice that that green triangle right there contains the number 1 marking and the number 2 marking all by itself. See that? And the other green triangle that we highlighted, which is this one right here, also contains a number 1 marking and a number 2 marking. That means we've got two sides congruent between those two triangles. Now look at this last line right here. UV is congruent to UV. That means that this side is present in both of the green triangles. In other words, what we're saying is in UV in one of the triangles is the same length as UV in the other triangle. Okay? When something is congruent or equal to itself, that was an example of our reflexive property. This happens to be object language, right? So then this is going to be reflexive property of congruence, because we're working in object language. And we can put a 1, 2, 3 marking on that one. Okay, again, I'm going to go back and I'm going to show you the two triangles that we're trying to prove. Let's start with the first one, UVW. UVW is this triangle right here. And look, we've got a 1, 2, and 3 markings on the side. Did you see that? On triangle UVW, there's a 1, 2, and 3 marking. Now let's look at VUX. A 1, a 2, and a 3 marking. So are those triangles congruent? Yes. Yeah, and by what theory? By what theorem? Do we know anything about angles inside? It's side, 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 right? Because we've got all 3 sides. And so these 3 triangles would be, or these 2 triangles would be congruent because of the 3 sides, side, side, side.